Physics began as an attempt to describe what could be seen: motion, weight, distance, heat. The world appeared mechanical, predictable, and ultimately understandable. Early physics was not interested in mystery, it was interested in control. If the laws could be written down, the universe could be anticipated. For a long time, this worked extremely well. Planets followed equations, machines obeyed rules. Nature behaved as if it were willing to cooperate with human intuition. The universe felt readable, solid, reliable, and from this reliability emerged a quiet assumption that reality, if studied long enough, would eventually reveal everything. That assumption did not survive. As physics looked deeper, the universe began to resist description, not violently, not dramatically, quietly. Equations stopped aligning with intuition. Concepts that worked perfectly at human scale collapsed at smaller ones. Reality did not disappear, but understanding fractured. The first fracture came with time. Classical physics treated time as absolute, flowing the same everywhere, for everyone. Relativity broke that illusion. Time slowed down, stretched, bent. It depended on motion, gravity, perspective. What felt universal turned out to be conditional. The second fracture came with matter itself. At microscopic scales, particles refused to behave like objects. They had no definite position, no clear path, no fixed identity. They behaved like probabilities, like tendencies, like something halfway between existence and possibility. Physics did not expect this. It did not ask for mystery. It encountered it. Quantum mechanics did not arise because physicists wanted a strange universe. It arose because the universe demanded it. Experiments forced it. Reality refused to behave in any other way. And so physics adapted, reluctantly, to a world that could no longer be described as solid. This is where many people misunderstand physics. They think quantum mechanics is about weirdness, about paradoxes, about thought experiments meant to confuse. It is not. Quantum mechanics is about limits, about where classical ideas stop working, about what remains when intuition fails. At this point, physics stopped being only about prediction and became about humility. Because something became clear, reality does not owe us simplicity, it does not owe us clarity, it does not owe us a form that fits inside language. The universe functions whether we understand it or not. Our models are not mirrors of reality, they are approximations that work until they don't. This realization changes the meaning of knowledge itself. Knowledge is no longer a path toward certainty. It is a tool for navigating uncertainty. Physics does not tell us what reality is, it tells us what reality refuses to be. It shows us the boundaries of our descriptions, not the essence behind them. Gravity and quantum mechanics coexist in the universe, but not in our equations. This is not a small technical problem. It is a deep fracture. Two of the most successful theories ever created cannot be combined without contradiction. Reality works, our understanding does not. This is why theories like string theory appear, not as answers, but as attempts to keep going when observation ends. Mathematics moves forward where experiments cannot. Physics becomes abstract, not by choice, but by necessity. At this stage, physics is no longer about seeing. It is about consistency, about what can exist without breaking the structure of logic. Reality retreats further from intuition and closer to silence. This is uncomfortable, especially for a species that built its confidence on explanation. But there is something important here, something often missed. Physics did not fail. Our expectations did. We expected reality to be fully accessible, to be fully representable, to be fully understandable. Physics shows us that this expectation was never guaranteed. The universe is not designed to be grasped. It is designed to function. When this is understood, physics becomes something else entirely. It stops being a collection of answers and becomes a disciplined form of questioning, a way of staying honest in the presence of the unknown. This is why physics matters beyond equations. It trains the mind to accept limits without surrendering curiosity, to investigate without demanding closure, to explore without turning mystery into mythology. This channel exists in that space, not to explain everything, not to simplify reality, not to promise understanding, but to stand at the edge where physics reaches its limits and look carefully. Here, physics is not reduced to spectacle. It is treated as a serious encounter with reality, a reminder that the universe is not obligated to fit inside human narratives. That certainty is not the measure of truth. Física não é conforto. Física é confronto. Confronto com o fato de que o mundo é mais profundo do que nossas ideias sobre ele. Confronto com a possibilidade de que nem tudo será resolvido. Confronto com o silêncio que surge quando as explicações param. And yet, something remains. Reality continues. Experience continues. The universe does not pause because we are confused. There is a quiet stability beneath all models, not a stability of answers, but of presence. Physics points to it indirectly, by showing us where our descriptions fail. Observation points to it directly, in the simple fact of being aware at all. This channel explores that intersection, where physics ends and attention begins, where knowledge stops expanding and awareness deepens, not as belief, not as spirituality, but as careful, honest inquiry. This is physics without spectacle, without shortcuts, without promises. Only the universe as far as it allows itself to be known. Still within,